So today we're going to talk about theoretical versus experimental probability, and this is the start of Unit 7. So the color for that is pink. All right, so vocabulary review. Probability. A probability is a ratio expressing the likelihood that a certain event will occur. The probability of an event occurring is the ratio of favorable outcomes to the total number of outcomes. So it's what you're looking for out of the total. Event is a subset of the sample space. Example would be flipping a heads on a coin. That would be an event. The sample space would be heads or tails. Drawing a queen of hearts, and the sample space for that would be a whole deck of cards, and the event would be getting the queen. Being born a female, the sample space would be being born a male or being born a female. Owning a dog out of all the different pet owners as your sample space. Rolling a prime number on a die, 1 through 6 would be your sample space. And winning the lottery, that would be an event out of everybody who bought lottery tickets. So the sample space is the set of all possible outcomes of an experiment. So example, flipping a coin results in 2 outcomes. You could either have heads or tails. So the sample space is heads, comma, tails. And usually we can abbreviate the sample space with an HT or the first letter of whatever we're studying. And an outcome is just the result. How did your experiment turn out? Your outcome. Makes sense. Okay? Theoretical probability. Theoretical probability is the exact probability that can be found with a formula. So the theoretical probability right here, it's the number of possible favorable outcomes to the total number of possible outcomes. So for example, in theory, on a die, if I roll a 1, the probability of rolling a 1 on a die would be 1 out of 6, or on a number cube. Remember, when we were talking just a few minutes ago, I like to write out my sample space. It helps me see the probabilities. Okay, the probability of rolling an odd number. Well, if I look at my sample space, I've got 1, 2, 3 odd numbers. So that would be 3 out of 6, or 1/2. Probability of rolling a prime number. 2, 3, and 5 are all prime numbers, so that would be 3 out of 6, or 1/2. So theoretical probability, that's the formula in theory. Okay, experimental probability is determined by actually carrying out an experiment or a simulation. Okay, so experimental probability, we go with the number of times the desired outcome occurs over the total number of trials in the experiment. So if we look at this right here, we can actually conduct a little experiment by rolling a die. So if we roll the die 10 times, we record the results. So the first time is a 5, so we'll put a tally in 5. A 1, another 1, a 2, another 2, a 6, a 5, that's 7, 8, that's a 5, 9, and a 2 would be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so in my little experiment, I rolled a die 10 times. The probability of rolling a 1, so I look in my table at 1. I've got 2 tally marks, so my experimental probability would be 2 out of 10, or 1/5. The probability of rolling an odd number, my odd numbers are 1, 3, and 5, so I look at the number of times I've rolled an odd number, and I get 1, 2, 3, 4, 5, 5 out of 10. Which would be 1/2. And then the probability of rolling a prime. My prime numbers again are 2, 3, and 5. So that gives me 1, 2, 3, 4, 5, 6 out of 10, or 3/5. So notice now you can compare your theoretical and your experimental. They're pretty close, but they're not identical. The probability in theory of rolling a 1 is 1 out of 6. In our experiment, it was 1 out of 5. Pretty close, but not exact. Sometimes you will get exact. Probability of rolling an odd here was 1/2. 3 out of 6 numbers have odd. Or, in our experiment, it was 5 out of 10, which was also 1/2. So that can happen. And then rolling a prime, here we had 1/2, and here we had 3/5. So again, pretty close, but not exact.